So, a couple of steps for solving radical equations. In order to get rid of a square root, you're going to have to do the opposite of square rooting, which is squaring. So if we want to get rid of a square root, we're going to have to square. So one of the first things we're going to try to do is isolate, if we can, isolate the square root all by itself. If it was a cube root, we'd isolate the cube root. So can we get the square root all by itself on one side of the equation? By doing our normal algebra of adding, subtracting, multiplying, and dividing. Then once you've got it isolated, then you can get rid of it by squaring both sides. And later on, we're going to do some where you have more than one square root in an equation. So I'm going to put as a step 3 in here, repeat. Because if you have two square roots in an equation and you square both sides once you've isolated one, you're going to still have a square root, and then you'd have to isolate again and square again. But for the most of our questions, step 1 and 2, isolate the square root by itself and then square both sides is going to work. So for A, if I wanted to isolate the square root by itself, what would I have to do? I have 3, 4, square root of x. There's a 4 in front. I could divide by 4. If I divided both sides by 4, can you see that I would get 3 over 4 equals the square root of x? Yes? That's right, it's a 4 times. If it was a 4th root, it would be a little 4 up in there.
So you divided by 4?
I divided both sides by 4. That isolated the square root. Now that I've got my square root isolated, if I would like to square both sides, what happens when I square 3 over 4? What happens when I square a square root? Square root just will become x, right? Square root of x all squared. They'll cancel each other out because they're opposites. And 3 over 4 squared will be 3 over 4 times 3 over 4. Multiplying fractions, multiply the tops. 3 times 3 is 9. Multiply the bottoms. 4 times 4 is 16. Okay? So you can isolate the square root. Sometimes people, I'm going to do this same one. Sometimes with multiplication, if you want to, we could have squared right away at the beginning. Because it's an equation, so what you do to one side, you can do to the other side of the equation, and that still will always work. But there's some math that doesn't make sense, and you're not going to add 5 to both sides of the equation because it's not going to help you. Right? But if you had, right at the beginning here, squared this side and squared this whole side, it will still work. The thing that I recommend isolating first is sometimes when people square this side, they forget that squared means multiply by itself, right? So 3 squared, it means 3 times 3. I wouldn't have to write that out. But 4 root x squared means 4 root x times 4 root x. Does that make sense? And here I'm going to get 9. And here when I multiply, I'm going to get 4 times 4 is 16. And root x times root x will be root x squared, which is just going to be x. And then you'd have to divide both sides by 16, and you get the same answer. So whether you isolated first and then squared, or squared first, you're going to get the same answer in this situation. But whenever you're adding or subtracting, like in part B here, we will need to isolate our square root. And there's this minus 7 right now on that side. So the first thing I'm going to need to do, add 7 to both sides. That will give me 20 equals 2 root x plus 1. And I'm going to isolate it completely by the next step, dividing both sides by 2, because that will cancel out those 2's, and I'll get 10 equals the square root of x plus 1. Now that I've isolated the square root, step 2, square both sides. 10 squared becomes 100, and the square root and the squared will cancel each other out. Subtract 1 on both sides. 99. I divided by 2 here so that I could isolate my square root. Questions on that one?